Okay, section 3.1 is notes for properties of exponents or the rules for exponents. So rather than fill in this chart, I'm going to fill in as I go. So I'm going to go ahead and start with a problem down here. Oops. It would help if I had the right feature going. Okay, there we go. All right, so I'm going to prove it, do a little proof for you the first time here, and then I'm not going to bother after that. So if we're doing a multiplication problem, I think it's pretty obvious that we're going to take the two numbers, the -3, called coefficient, and the +4, and we're going to times them together. We're going to get -12. But quick proof for you. Question would be, what do you do with the exponents? Do you add them? Do you multiply them? Do you subtract them? What? So I would say to you, what does x squared mean? Hopefully you would respond with this. X squared means x times x. And what does x to the fifth mean? Well, it means that you would have 5x's being multiplied together. And then if you took and multiplied those two sets of x's together, how would you write that? Well, I see 7x's. So I think it's a little more obvious right now that guy would end up being a 7, which means we just added the exponents. So the shortcut would be to take x to the second, a 2, x to the fifth, and 5, and add them up, and we got x to the seventh. So up here in the chart, for a multiplication problem, I'm just going to use the symbols. The coefficients, or the numbers out in front, in that case the -3 and the 4, we just times them. But the exponents, we added. So one thing you can look at in this chart is you never do the same thing with the coefficients as you do with the exponents. So if you were thinking about multiplying, those exponents in that problem wouldn't have made any sense because coefficients is what we multiplied first. All right, for number 2, understood to be a coefficient of 1 right here for this guy. So I get a 1 and a 9 and a 2. So simple multiplication problem. I'm just going to multiply them together and I get 18. So let's do them one at a time. I see an a to the third. I see an a, which is understood to be an exponent of 1. And that's a total of, if I add them, a to the fourth. I got a b to the second, a b to the fifth, and then this guy's understood to be a b to the 1. So that's 2 and 5 and 1 for a total of 8. Well, that was a terrible b. And it's really that easy. Equal signs. All right, this last guy. First thing I'm going to do is see that there's a negative times negative. So I know my answer is going to be positive. The first set of parentheses would be understood a coefficient of 1. So I get a -1 times a -5, 5. So that rule makes some sense. You're doing a multiplication problem. Well, duh, you got to multiply something. But then here's the part that's just as easy as long as you remember the rule. M to the 1, m to the second, total, m to the third. N to the 8, n to the 1, total, n to the 9. Okay, now what do we do to the p to the 6? Well, there's no other p's to add it to, so I'm kind of stuck with it. P to the 6. That's it. So multiplication problems, assuming you remember the rule, the set of rules for the exponents is pretty darn easy. So the second one, raised to a power. So for number 1, you would say there's different ways of saying it, but you could say it's y to the third raised to the fourth power. So again, I'm going to do one proof for you, and I'm not going to do it again. Y to the third, based on what we just did a minute ago, would mean that. And then I'm supposed to take that times itself 4 times. Oops, one too many. And I'm going to squeeze one or put one back out in front here. So there's 4 sets of y to the third, and that's exactly what that problem means. So how would you write all those y's being multiplied together? There's 12 of them total. So it's y to the 12th. So what did we just do with the exponents? We multiplied them. And understood to be a 1 in front. So if I took the 1 and raised it to the 4th power, well, what's that mean? It means 1 times 1 times 1 times 1, which is 1. Wouldn't have to write it down there with the answer. But the point being, let me scroll back up here for the chart. If we're raising to a power, we times the exponents. And then for the coefficients, now it depends on what you're talking about. If you're squaring something, you square it. If you're cubing something, you cube it. So there isn't a symbol for that so much. So I'm just going to write raised to a power. And that can be done with a calculator. All right, so let's pick up these other examples. Now I'm going to leave that -3 for last, and I'll show you why in a second here. So easy part, again, assuming you remember the rule, times the exponents. So I get a 2 for r, and I get a cubed outside, and I times them, I get 6. I get a q to the 5th raised to the 3rd power. If I times those exponents, I get 15. Now here's why I left the -3 for last. So it'd be really tempting to write -9 there, but that would also be multiplication, and we never do the same thing with the coefficient that we do with the exponents. So maybe try this. Do the exponents first because that's the easy part. Now I'm going to cross these guys out because we've already done it. -3 raised to the 3rd power. Is that something you could do in a calculator? And the answer is yes. So if you type in -3 cubed on a calculator, it's going to tell you -27. Okay, now how did we get it? Well, it's -3 times -3 times -3. But hey, pick up a calculator. So for number 3, don't let the fractions scare you. Here's something that most people don't realize. First of all, I'm going to do the exponents. And again, if we know to times them, pretty darn easy, w to the 12th, and that's it. So a fraction is just like doing two problems. There's a 2, there's a 5. Well, what's 2 squared? Everybody knows 2 squared is 4. What's 5 squared? Well, everybody knows 5 squared is 25. So guess what 2/5 squared is? It's 4 over 25. It's as simple as that. That's all you have to do. All right, before we do the division problems, I'm going to scroll back up. See if you can guess. If on a multiply problem, we multiply. If on a raised to a power, we raise to a power. So for divide, guess what? We're going to divide. Why am I going to write divide? I'm going to put a divide symbol. I was about to write divide. So any guesses for what to do with the exponents? Well, if you guessed subtract, you would have been right. So let's try these guys down here. Examples with division. So in other words, you just want to treat the problem like two separate things. I'm going to do the coefficients, 44 divided by 11, which is 4. And I'm going to subtract the exponents. End of the third. Done. So for number 2, I'm going to divide the coefficients first, coincidentally also 4. And then I'm going to do the a's first, but then I'm going to give you a proof part for the b's. So I get 7 a's on top, I got 1 a on the bottom. If I subtract them, I get 6. But what do you think? Does it make a difference that the b to the 4th is on the bottom? The bigger exponent's on the bottom. So here's a proof for how you get this answer. And I'm just going to do kind of the same thing we were doing a minute ago. If you know b to the 4th means this, and on top we know b to the 2nd means this, am I allowed to cancel things top and bottom of a fraction? And the answer is yes. Cancel b, cancel b, cancel b, cancel b. So how many b's are left? There's 2. So you can still think of it this way. We're still going to subtract the exponents for these guys. But I don't want to create a negative exponent. Negative exponents are a no-no. And if you watch some of the videos coming up here, we're going to explain to you what to do with negative exponents. For the time being, really all we have to do is ask ourselves, if I subtract 4 and 2, forget a negative sign, right? I'm going to get b to the 2nd. Well, where in my little example here did the b's end up at? The extra b's were left on the bottom. So how do you know that based on the original problem? Simple as this. Where was the higher exponent? So for the a's, the higher exponent was on the top, so I wrote the answer on the top. For the b's, the higher exponent was on the bottom. I wrote them on the bottom. So for number 3, let's try that. So now I get 3 over 9. I'm not really dividing those. I'd be reducing it. Another name for division, right? So if I reduce 3 over 9, I get 1/3. Negative divided by a positive is negative. So if I have 1x on top and 3 on the bottom, I want to subtract them. But since the bigger number is on the bottom, that's where I write it. I got 1t on top and 2 t's on the bottom. I subtract them. The bigger exponent was on the bottom. And z to the 10th and z to the 10th, if you subtract them, leaves you 0 z's. All right, guys, so if you would like to see some more examples, including examples D here, which is where you got to do more than one thing, and negative exponents are coming up as well, check out the other videos. Thanks for watching.